Okay, so good morning again. Today we'll discuss the periodic review model. We'll just go through this very quickly. So if you see on the right side of your screen, okay, so you see this cursor here. So this is the diagram for the periodic review problem. As you can see, if we start here at period 0, you will have demand during lead time, okay, that consumes your inventory. And then the highlight of this inventory model is that you will have uh, a review period. So let's say that your review period starts here, okay? Your review period starts here. So when you say review period, and you will see it here, it is the elapsed time between, TR is the elapsed time between two successive reviews. So you will see it here, right? So in this example, TR is equal to 3 weeks. So you will see the timeline written here. It could be days, it could be weeks, it could be months, okay? And that is denoted by capital T. So in this example, TR would be in weeks, okay? So you would have this. Let me just encircle it. Okay, TR would be in weeks. So now, um, when you come to the review period in the inventory cycle, so let's start here, it means that you have to place your order. Okay, so when you do the review, it means that you are going to physically count your inventory level. And for simplicity, let's just imagine that there's just one product. You're going to physically count the quantity of inventory in your warehouse. So when you do so, you know how much you have, and therefore you have to place your order. So at this point, you will place your order, but there is a lead time. When you place your order, your supplier cannot deliver it instantaneously. So there is what we call L, which we denote as the lead time of the supplier. So in this example, the lead time is 2 weeks. So just take note of that. Okay, the review period is every 3 weeks. The lead time is 2 weeks. So once you place your order here for 2 weeks, okay, there will be no replenishment, okay, for 2 weeks. So what happens is the demand will slowly deplete your inventory level. So let's say you start here when you're reviewing the inventory, this is your inventory level. Okay, it's depleted by demand. And you will see that it goes below 0, right? So it goes to this point, which means that there is demand that is not fulfilled, but you are allowed to fulfill it sometime in the future. Okay, so that's fine. So we call this quantity here, if you look at this level here, we call this quantity here the number of units back ordered in this review cycle. So anyway, so 2 weeks has elapsed. Finally here, the supplier delivers your order. So when the supplier delivers your order, inventory will be replenished. So again, this review period is the time when you place the order. This period after the lead time is when the order is replenished. And you will see here that there is a target inventory level for a periodic review model. And that target review, target inventory level is your M. Okay, and it is defined here. Okay, it is defined somewhere here, right? That's your target inventory level. So you will see that when you replenish your inventory, the level will just be M minus mu of X. Okay? Since this demand, this black line here, the demand during lead time that depletes your inventory upon review, okay, is denoted as X. There is a probability distribution f of X, this black line here, okay? And this probability distribution will have a mean which is known as mu of X, okay? So therefore, whatever this mean is, okay, your highest point, the highest point of your inventory will be your target inventory level minus the mean of the demand while you're waiting for that inventory order to arrive. Okay? So any questions so far? So you have a target inventory level. Okay, say that's 100 units. Okay, so when you place the order here at this point, your target is to replenish it back to 100. Okay, so if let's say this level here is 40 units, what you will do is after the review, after the physical count, you will place an order here for 60 units because you have 40 and your target is 100. But when you place an order for 60, there is demand for 2 weeks, right? So let's say this demand for 2 weeks is 10 units. So what happens is, since you have 40 here and you ordered 60 and demand during lead time was 10, then when you replenish the 60 here, what level will this be, class? Anyone? You have 40 upon review. The average demand during lead time is 10 units. And you ordered 60 here to replenish it back to the target level, 100. So by the time the order arrives and replenishment happens, what would be your inventory level after replenishment?
90 po, sir.
90, correct, right? So because you have targeted it to be 100, but you have an average of 10 units demand during lead time, then this level here will be 90. Okay, so now what happens here is that you have to pay attention to the lead time, L is equal to 2, to the review period, TR is equal to 3. So this means that every 3 weeks, you have to perform a review. So you'll see it here. So on the 3rd week, review again what the inventory level will be. So you will see that the inventory level will be at this point when you review. Okay, and then there's demand during lead time. You will order here again, but it will take 2 weeks, okay? 2 weeks before inventory or before the order arrives and inventory is replenished. So once inventory arrives from the supplier, it will be replenished back to M minus mu. And then the cycle continues. As you can see, there will always be demand during lead time. So if this is your review period every 3 weeks, so on the 3rd week, 6th week, 9th week, 12th week, and 15th week, okay, and so on, okay? And then every time you get to the review period, there will always be a lead time of 2 periods before you will see replenishment happens. So if this is the review period, this is where after 2 weeks, the replenishment happens. If this is the review period, okay, period 6, this is your inventory level. There is demand during lead time. After 2 weeks, you will see a spike again, okay, where that represents the replenishment. So it's interesting to note that in different inventory cycles, you may have back order, meaning to say that your inventory level, okay, can no longer satisfy the demand during lead time, and therefore you will have back order quantity here. But there are review periods like in this one, okay, you reviewed inventory, this is the level. This is your demand during lead time, and therefore your inventory level upon review is enough to satisfy this demand during lead time. Okay. And therefore, you stayed positive in terms of inventory level. No back order needed. So here again, when you reviewed on the 6th period, your available inventory did not satisfy the demand during lead time completely. So here you have back order again represented by this quantity here, and so on. So it's possible that you won't have back order, but it's also possible that you will have back order like in these 3 cases, here, here, and here. Okay, and these are the cases where there's no back order. So now, if this diagram is clear to you regarding periodic review, we need to, I think everybody needs to understand the parameters indicated in your PowerPoint, no? Forgot what slide that is, but you can go to your PowerPoint and let's go one by one. So L is lead time, you already know that. So that is the one in green here. Okay, that's 2 weeks in this example. Okay, X, okay, as I've said, that's the demand during lead time. So the 2-week period where you're waiting for your order to arrive. Whatever demand happens there, everything in black, okay? Whatever demand happens there is your demand during lead time. Everything in black starting from the review period, okay? Starting from the time that the order was placed until the time that the order arrives, okay? The time the order was placed here, coinciding with the review period until the time the order arrives. So you will see these points, right? This to this, that's your demand during lead time, and it's random. Okay, this to this, that's your demand during lead time. This to this, again, demand during lead time, demand during lead time, demand during lead time. Okay, here, demand during lead time again. And you will see that every time you see this demand during lead time, it's denoted by Fx because it's a probability distribution. Okay, so you have a probability distribution. And every time, class, remember this, every time you have a probability distribution, Fx is the probability distribution of your demand during this lead time period. Okay, this is the demand during this lead time period. Every time you have f of x, you should always have mean and a standard deviation. Okay, ulitin ko. Every time you have a probability distribution, you will have a mean and standard deviation. So mean of demand during lead time or average demand during lead time and standard deviation or variance of demand during lead time. Okay, so that is your f of x. So you see it here. Okay, f of x is the probability distribution of x, and it has mu of x and sigma of x, where mu of x is the mean demand during lead time, representing average of all the x values. Okay, so these are, okay, the x values you will see in the diagram. It's the mu is the average of all of these x values. Again, x represents the demand level upon ordering, okay, and the demand level upon replenishment. Okay, so these two, okay, the difference in their levels, which is this one, okay, this height here, is how much was consumed during the lead time. Okay, so lahat na tong x na to, from here to here, okay, so this vertical height here represents your demand during lead time x. Okay, now, important, in the periodic review model derivation using Leibniz rule, okay, another random variable which is related to your random variable x, okay, is PR plus L. The demand, sorry, is D, capital D. Okay, what is capital D? Capital D represents the total demand over one inventory cycle. And whenever I ask questions in the exam, about a cycle, an inventory cycle in the periodic review model, that simply means TR plus L. So one cycle is your review period plus the lead time. So in this problem, since your review period is 3 and the lead time is 2, then we say that from period 0 to period 5, TR is 3, lead time is 2, 3 plus 2, you have 5. So from period 0 to period 5, which is here, over here, okay? Period 0 to 5, that is one inventory cycle, okay? From period 3, with the time that you start your review again, okay, all the way up to period 8, okay, 3 to 8, which is this, a period of 5, a span of 5 periods, that is another cycle, and so on and so forth. So TR plus L equals 5 in this example is one inventory cycle. And the demand that happens in 5 weeks or in TR plus L is also a random variable. And hence, it has its probability distribution. Okay, so FD is the probability distribution of the total demand that happens in TR plus L. Okay, I hope that's clear. And since it's a probability distribution, then it also has its mean mu D, just to differentiate it from mu X. Okay, average demand during lead time ito, and average demand during TR plus L ito, during the whole inventory cycle. Obviously, the average mu D is greater than mu X because mu X is just the average during the lead time. Okay, average of demand during the lead time, whereas mu D is the average of the total demand during lead time plus the review period. So mu D will definitely be greater. Okay, same goes with sigma D. Okay, now, if the probability distribution of X, let's say, is normal distribution, then we say that the probability distribution of the total demand in TR plus L is also normal. So you will see that this pattern continues. So if you have this pattern, so this is the start of your review period, right? And then this is your demand pattern. You will see that this demand pattern will continue until the 8th week, from week 3 to week 8. So if this is normal, then the whole demand, the total demand from week 3 here to week 8 here, if we continue this, okay, will also be normal. Okay, so later on, I will explain further how this is applied in a problem. So what we will be interested in, okay, in solving periodic review problems is this one. Okay, so this is what we will be interested in, F of D, and this one. Okay, the total demand over one cycle. Right? Now, let's go to BM. BM is, in your PowerPoint, no, it's the expected number of backorder units. Or in this diagram, you will see that there are some cycles where you have backorder units, like in this cycle, and this cycle, there are backorder units. But in some cycles, there are no backorder units. Get the average for all of the cycles. Get the average backorder units for all of the cycles. That is what you call as BM. Okay, average of all the backorder units per cycle. Okay, and for your small d and h, this is important. Okay, small d, we've been talking about demand during lead time, that's X. We've been talking about total demand over one inventory cycle, that's capital D. Small d is just the average demand, okay? It is just the average demand per T, okay? Per period capital T. And I explained earlier that your capital T is dependent on your TR. Here, if your TR is expressed in days, listen here, if your TR is expressed in days, okay, let's say you review inventory every 5 days. Okay, then your capital T is day, meaning your holding cost should be expressed in terms of per unit per day, because that was how the derivation of the expected cost was done. So if your capital T is in terms of days, and you will know if it's in terms of days, your TR should be in terms of days. Okay, so therefore, TR dictates what capital T should be. Okay, again, TR dictates what capital T should be. If your TR in this example is in terms of weeks, in this case, 3 weeks, then your capital T is in terms of weeks, and therefore, your holding cost should be expressed as holding cost per unit per week. Okay, and the definition of your small d should therefore be the average or expected demand per week. Okay, again, if capital T, which is dictated by TR, let's say TR is 5 days, so capital T is in days. So when you calculate your expected demand, small d, it should be expected demand per day. Holding cost per unit per day. In our example here, since TR is 3 weeks, then capital T is weeks, so your small d should be expected demand per week, and H should be holding cost per unit per week. Okay, I hope that is clear. If it's not in terms of, if the problem does not give it in terms of capital T, then you just do the conversion, okay, before you apply it to the formulas under periodic review model. Okay, so if it's given, let's say, so in this problem, it's weekly, no, yung every 3 weeks yung TR. So if the holding cost is given in terms of, let's say, holding cost per unit per year, for example, then you just divide the holding cost, the given holding cost, by 52 weeks in 1 year to get the holding cost per unit per week. Okay, so what's important here is you identify what capital T is before you solve for small d and small h. Okay, and small d can be derived from x. Okay, or small d can be derived from capital D. The same way, capital D can be derived from x and small d. Okay, because they represent demand during these cycles. Okay, so you can just multiply or divide, no, to compute small d, capital D, and x. Right? So this one we're done. P is the cost. Every time you have back order and you do not fulfill the order on time, so when you deliver that to your customer, there's a penalty cost. No? So that's the cost per back ordered unit. And we already know A. A is just the combined cost of ordering, the fixed cost of ordering, and the review cost that happens here, 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 and here. Okay? So that's just for one cycle. All of this is just for one cycle. No? So the combined order cost and review cost is for one cycle. Okay? And then E of C, as I've said, is the expected cost per T. So in your derivation, using the Leibniz rule, it was derived with the assumption that you are computing the average cost per T. So if capital T is in days as determined by your TR, then EC should be expected cost per day, automatic. In this example, if your TR is 3 weeks, so your T is, capital T is in weeks, so automatic, your expected cost formula, okay, your expected cost formula will give you the expected cost per week. Okay? So now, in the exam, if I ask you, what is the expected cost per cycle, for example? Okay, what is the expected cost per cycle? Then, all you have to do is apply the EC formula, expected cost formula, and you know that that expected cost will be the expected cost per T. So after computing it, all you have to do, like in this example, you are computing the expected cost per week. So to convert it to expected cost per cycle, how many weeks is one cycle again? In this example? Anyone? How many weeks is one cycle? One cycle?
5, sir.
5 weeks, diba? That's your TR plus L. Okay, that's 5 weeks. So all you have to do is, since you have already calculated the expected cost per week, you just multiply that cost by 5. Okay. Is that clear? So if you want expected cost per year, pwede rin. Just multiply the weekly cost by 52. Since expected naman yan, average. Okay. So you can do all those conversions now depending on what is being asked in the problem. And of course, the main highlight of this periodic review model is your M, which is the target inventory level. Okay. So that's about it, no, for periodic review. To summarize, whenever you review your inventory, you go to the warehouse, you take a physical count, okay, of your inventory in that cycle. And if you have many different products in your warehouse, then you can just choose to do cycle counting, meaning you can choose, let's say, 10 different products for this particular cycle. You can do an inventory review for those products. Let's say those are the 10 critical products that you have, or the most saleable ones. Okay, and that's what you are interested in monitoring. Okay, that's what you're interested in monitoring. So what you'll do is you'll take those 10 products, count them physically, know what their inventory level is this one, okay, this one, know what the inventory level is, so that you know how much to order. Okay, and how much to order will always be based on your target inventory level, okay, minus the inventory level upon review. So as I've said, if inventory upon review is 20 units and your target is 100, your order quantity will be 80. That's 100 minus 20. So it will always be M, okay, M minus the inventory level upon review. That is what your order quantity will be. Okay, you always bring it up to the target inventory level. And then you just allow demand to deplete whatever you have upon replenishment. So here, upon replenishment, you have this. You allow the demand to deplete it. Okay, and sometimes there will be back order, like in this case. Sometimes there will be no back order, like in this case. So every time your inventory level is replenished, you just allow demand to deplete it, and the cycle continues. Okay, and these are the parameters that you need to understand, the parameters and your variables. What we are solving for, okay, in the periodic review problem is this one. This is what we are solving for, the target inventory level, okay? And your random variables are X, this one, and D, this one. But as I've said, this is what we're interested in, no? Because the formulas were derived using the probability distribution of the total demand. Okay. So if there are no questions, if that is understood, let's go to, okay. So problem number 1, if you can see it, I hope you can see it, is your problem in the PowerPoint. And this is what I want to clarify and resolve. Okay, so let us do this. Okay, so let's do number 1. Okay. Not that used to this, so just bear with me. Can you see the problem on the screen, the left side of the screen? If you cannot see it, it's in your PowerPoint. That's the problem in your PowerPoint. Example 9, I believe. Okay, so let's do this. So again, the first step in solving a periodic review problem is to identify the given information. Okay, so let's go line by line. Assume that an item can be ordered at a cost of 20. Okay, so again, this is not purchase cost because we don't have purchase cost in our formula. So this is obviously ordering cost. So if you go back to the notation, what is the notation for ordering cost?
A.
Okay, A. Thank you. So that we can finish, I hope if you know the answer, you just give the answer. So A represents the ordering cost, but it's the combined ordering cost and review cost. So you have to scroll through the problem and look for the review cost because every time you're reviewing, you need people to do the physical count, diba? And do the encoding of the inventory level, right? So you have to look for the review cost and add it. So what will be the value of A?
30 po.
30, sir.
Okay, it's 30. Thank you. Right? It's here. I don't know if I can. I cannot. So 20. Okay, you will see it here. This is the cost 20, if you can see. And then this is the review cost 10. So A will be equal to 20 plus 10. That will be equal to 30. Okay, let's go quickly. Next, it costs 1 peso per unit per week to store the product, and 5 is incurred for every item back order. So what is the 1 peso per unit per week?
H po.
Okay, H is equal to 1. Okay, important, we put here 1 per unit per week. Okay, and then what is the 5 pesos?
P, sir.
P, sir.
Okay, sige. P is equal to 5 per unit back ordered. And next, lead time is 1 week, no? So you just put there L is equal to 1 week. Okay, then tapos na yung review cost. Then assume that the demand per week is normal. Okay, so here you have demand per week is normal. So when you say normal, it means it's a probability distribution, right? And our random variable is demand per week. Okay, so you will see it here. Demand per week is normal. But our random variables X here, okay, X here, if you still see it, X is the demand during lead time, and capital D, FD, is the probability distribution of total demand. So no problem with that. If it says that the demand per week is normal, it means that, what is your lead time again? 1 week lang pala, no? So therefore, the demand per week is also the demand during lead time. Agree? Agree ba kayo? Demand per week, since lead time is 1 week, then demand per 1 week is your random variable, right? That's the demand during lead time. And the probability distribution is normal. So X is the demand per week in this problem because lead time is 1 week. And f of x is said to be normal. Okay, normal distribution. And every time you have a probability distribution, you need to look for the mean and the standard deviation, no, if given. So in this problem, it says here that mu, the demand of X, okay, meaning average demand for 1 week ito, okay, is 12. And the variance of X, okay, lagay ninyo yung ano ha, subscript ha, okay, kasi the 12 is the demand of X, which is 1 week. Variance of X, which is 1 week also, is equal to 1. Okay, so you're now asked to find the target level of inventory if the review period is 2 weeks. So here, we will now write down review period TR is equal to 2 weeks, meaning you do physical count on your product or products every 2 weeks. Okay? So that also means, if TR is 2 weeks, that also means that you place an order with your supplier every 2 weeks. Okay? So again, if TR is 2 weeks, it means that you place an order with your supplier every 2 weeks. And if lead time is 1 week, after placing the order with your supplier, replenishment comes 1 week after you place the order. Okay, so that's what it means. So we have written down all the given information in the problem. So what I suggest when you solve periodic review problems is after you write down the given, you write down the highlight, no, which is capital D. Okay, capital D is the total demand. Okay, during TR plus L. Okay, so as mentioned here earlier, it is the total demand over one inventory cycle, TR plus L. So by definition, in this problem number 1, capital D is the total demand for how many weeks?
For 3
So,
weeks.
lagay muna natin dito. TR plus L is equal to, TR is 2 and L is?
L is 1.
L is 1, right? So 2 plus 1, so that will be equal to 3 weeks. So therefore, capital D will be the total demand per 3 weeks. Okay? Now, it's important after writing down all the given, because the problem will not give you capital D. Okay? You just have to figure it out from TR and from your L. And then, of course, since capital D is a random variable, okay, along with X, then you will have a probability distribution for capital D as well, the total demand per 3 weeks. And that probability distribution will follow whatever probability distribution is given to you. So if f of x, the demand per 1 week is normal, then by convolution, f of d is also normal. And if it is also normally distributed, it should have, okay, it should have a mean also, and I will put a subscript here, the mean of your total demand per 3 weeks. And you have to calculate that from the total demand, so let's put it here, 12 per week, and this one is 1 per week. Okay, so if your mean is 12 per week in a normal distribution, what will be the mean of the normal distribution if you have 3 weeks? The mean demand if you have 3 weeks. If it's 12 per week, then what is mu capital D? So in your PowerPoint, you have, tama ba?
36, sir.
Okay, 36, di ba? Kasi 12 per week times 3. 3 weeks, di ba? So that's 36. That's where the 36 came from. Okay? And in my periodic review lecture number 10, okay, I inserted a few things there which I would like to correct. Okay, upon discussion with the other faculty members, I would like to correct that. And instead, please focus on this lecture. Okay, whatever I'll be saying in this lecture, you use this as your review material. So this time, what I'm going to say is that if capital D has a probability distribution and it's normal here, okay, capital D has a normal distribution, then you have to calculate mu D and variance first. Okay? Contrary to what I said earlier, no, that you have to express everything in sigma first. Now, I'm just telling the class that you have to calculate the variance first. Okay? So, depends on what is given. In this problem, the given for 1 week is variance. Variance is equal to 1 per week. So therefore, on the basis of the variance, you get the variance for 3 weeks. And therefore, it follows the same calculation. 1 per week times 3 will give you 3. Before you calculate sigma. Because ultimately, for normal distribution, you need mu and sigma. So since variance is equal to 1 and capital D is for demand for 3 weeks, you multiply that by 3. Okay? And then you calculate sigma of D. And therefore, sigma of D will be the square root of your variance. So that would be the square root of 3. This is now aligned to the calculations in your PowerPoint. Okay? That's aligned to the calculations in your PowerPoint. So now, if for example, sigma is given, okay? Sigma is given to be, let's say, 2. Okay? Sigma is given to be 2. So natin dito. Let's say, lang, example, sigma of x is given to be 2 in the problem. So that's 2 per week. So what you do is you calculate the given, convert the given to the variance first. So variance, if sigma is 2, what will be the variance?
4.
4, sir.
Okay, that would be 4. Now, if you want to calculate sigma of D, magkaibang variable yung x tsaka yung D, kaiba. X is in this problem 1 week, D is 3 weeks. You always have to be to pay attention to that. So if you want sigma of D, you base it not on sigma but on the variance. So since this is 4 per week, the variance, all you have to do is to calculate the variance of D. You convert the 4, which is 1 week, into 3 weeks. Is that clear? 4 per week times 3 weeks will give you a variance of 12. And then from there, you calculate sigma of D, which is the square root of 12, or 2 times the square root of 3. Is that clear? Before I proceed, I need this to be clear para no confusion in the exam. If ever the probability distribution is normal. Is it clear?
Yes, sir.
Okay. One person answered it's clear. Are there others?
Yes, sir.
Clear po,
Okay,
sir.
because if it's not clear, then you have to raise your hand, unmute yourself, and ask your question. Okay, so our basis will always be the variance first, and then before we calculate the sigma. So we'll have other examples later. So I can move on. So I'll erase this. And continue with our calculations. I hope we have enough time to finish all quickly. Okay, so once you have written down all the given, and once you have expressed capital D, FD, and its mean and sigma, then you're now ready to solve the problem. Okay, which is M. So there are steps in solving. The first step, okay, I'll number it, steps. Para hindi na kayo ma-confuse, di ba? Step 1. Step 1 will be to calculate the critical ratio, no? And you can refer to your PowerPoint. So the critical ratio will have an integral from M to infinity, f of D, dd. So that's simply, ito na lang ang gamitin nyo, use this. So probability, capital D is greater than M, okay, because the limits, if you look at the integral, is from M to infinity. So that's the random variable D greater than M. And that, for the formula for the critical ratio is H, ano na yun? H times TR all over T. Okay? So now, again, as I've said, the formula was derived based on these definitions here. Okay? Formula was derived based on these definitions here. And therefore, H has to be the holding cost per unit per T, and P should be the cost per backorder unit, and TR should be the elapsed time between successive reviews. So no problem with TR and P. Okay? The problem is always how H is expressed in the problem. So we go back. So H is here. Okay? So that's 1. I substitute, because this is in your PowerPoint anyway. TR is 2. Okay, that's here. And P is 5. So that's here. So 2 over 5 is 0.4. Okay. So after calculating the critical ratio, you now have an equation. Probability D greater than M is equal to 0.4. So all you have to do, since this is a normal distribution problem, you know the probability, you have to solve for M. Okay? So if you understand your normal distribution problem where you convert this random variable D to its equivalent Z value, and Z is just equal to, the transformation formula is just equal to M minus mu. Okay, this is capital D. Okay, your random variable is D, therefore your mean should be capital D divided by sigma of D. So this is your random variable. Okay, capital D. This is what you're computing, M. So that's the normal, that's for the normal distribution, because that's the hardest to calculate anyway. For other distributions, it's easy, you just have to integrate. Okay, so for this one, normal distribution, that's the transformation formula. So all you have to do is to get the z value from your z table, okay, of this one is greater. Take note that d greater than m is 0.4. That's the area to the right, okay, of the z value. But your z table will give you the area to the left. So therefore, this has to be, let me put this here. This has to be the z value of 1 minus whatever the critical ratio is. Okay, so that is equal to the z of with a 0.6, the z value with a 0.6 probability. So now, in the exam, please follow instructions, no? If you're given a z table, you have to use your normal distribution table, because there's a slight difference between what your calculator gives you and what the table gives you. Kasi the table is rounded up to 2 decimal to do 2 decimal figures for z. Okay? But for your calculator, it gives you actually the exact value, the interpolated value. Okay? So in your exam, when you look for the value of z, there's no need to interpolate. You just get the nearest z value to the probability. Okay, the nearest z value. Now, if that z value, if that probability happens to be in between, exactly in between two z values, then that's the only time you interpolate. If it's in the middle. But if it's not in the middle, then you just get the nearest z value if there are no instructions. If you see a z table, then automatically you use the z table. Do not use your calculator so that your answer will not be marked wrong. Okay. Now, if there's no z table given in the exam, then that means that you don't have a choice but to use your calculator for the z value. Okay. I hope that's clear. And for those who are absent today, I hope that they will get to this part of the lecture and know what I said. Okay. So, what's the z value? Okay, so that we won't waste a lot of time. If you go to your z table, this will be equal to 0.25. In your PowerPoint, I think it's 0.255, if I'm not mistaken. No? You can use that or you can use this. Okay, doesn't matter. It's 0.25 and 0.255. 0.25, I use the table, not the nearest value. Okay, so 0.25 is equal to your m minus the mu d that we calculated earlier, which is 36, divided by the sigma, which we also calculated based on variance to be square root of 2. Okay, and from here, you can now calculate your m. And m, okay, I calculated it already. The interest of time is 36.43. Your PowerPoint is 36.44. Okay, so this is your first calculation, and that's the first question that's asked in your problem. Find the target level of inventory M if the review period is 2 weeks. So if this is the problem, you're actually done. Okay, because it's just the target level of inventory being asked for. Okay, now just for purposes of showing you other calculations, what the problem can ask is for every cycle. By the way, the definition of BM is always understood to be per cycle. Okay? In the derivation, it was derived as the average backorder units per cycle, not per capital T. Okay, it's per cycle. So therefore, your random variable there is still capital D. So if you want to calculate BM, so this is the step for calculating M. If you want to calculate BM, okay, the formula for BM, the generic formula is you have to integrate, no? From M to infinity, okay? Your random variable is capital D, the total demand for the cycle, minus M. Okay, so that means that you will only have back order if your capital D here, if your capital D is from M to infinity. Di ba? Your capital D, your total demand in that whole cycle, okay, should be from your target level higher. Okay, higher than your target level for you to have back order. Okay, because if it's lower than your target level, then you would have enough inventory to satisfy the total demand for that whole cycle. And that's why you integrate, you add up all the values of capital D from M to infinity for you to have back order. Okay, so that is capital D minus M. Then the probability distribution of capital D, which we have here to be normal in this problem, and these are mu and sigma are the parameters of the normal distribution, and then TD. So for other distributions that are not normal, not normally distributed, you have to put in the probability distribution into this formula, okay? And then you have to integrate. Okay, so if it's an exponential distribution, you have to put it here. If it is a uniform distribution, you have to put it here, then integrate to solve for BM. But for normal distribution, you have a special formula to calculate the BM for normal distribution. Okay, and that special formula is the same as the special formula you had in the back order and stack out case. Okay, so in the back order and stack out case, we calculated BR, okay, the reorder point level, using this formula as well. So this time, you will have sigma, okay, if you recall, this should be sigma, nilelabel ko ha, sigma of D times F of, that time was R minus mu, di ba, over sigma. So this time, it will be M minus mu over sigma. Okay? So you have to go back. I think with the 1 week suspension, dapat nakapag-review na kayo. You go back. It's sigma times this quantity, F of M minus mu over sigma, plus you have mu minus M. Again, this is mu D minus M. Ano ba yung next? G M minus mu over sigma. Okay, basically this M minus mu over sigma is just your Z because it's a normal distribution. Diba? That's just your Z. Right? The Z transformation formula. Okay, so to calculate in this case, step 2, it will now be the sigma of D, which we have calculated earlier here. right? So this is the one. So you have square root of 3 multiplied by f of m minus mu over sigma. So the formula for f is, if you recall, 1 over square root of 2 pi. Then you multiply that by e raised to negative 1/2 of m minus mu over sigma. So what you do to calculate f is you just put the z value here. Okay, you just put the z value here. And the z value will be this one, right? This is your z value, 0.25. So you just put the z value here, 0.25 squared. E raised to negative 1/2, then the z value squared. Okay, so that does it for your f. And then plus, you have calculated your mu d earlier. This is the one. Okay, so you put it here, 36. And you have calculated your m earlier, and this is the one, 36.43 or 44 in your PowerPoint, multiplied by this quantity is your, to avoid confusion, let me remove this. This quantity is your H times TR over P, or your critical ratio, what you calculated earlier. So I go back here. That's the one. Okay. So whatever this is, you just substitute to your G. So this one will be times, what was that again? 0.4. Okay, that's times 0.4. So you calculate BM using this formula. That will come out to be equal to, I did not calculate anymore, no? But since I used 36.43, sorry, this should be 36.43 to be consistent with our M here. Okay, with our M here. So when you calculate, anyone? Is this still correct? This is the one in your PowerPoint. Is this still correct? Okay, quickly, so 15, is that still correct?
Yes, sir.
Okay, so if it's still correct, then that's it, right? And the third, so that's it. That's your BM. And always understand that the value that comes out of this equation is always per cycle, per inventory cycle, because your random variable in this equation is capital U. Okay. And lastly, these are actually not steps, no, but rather things that the problem may ask you to calculate.
Sir,
So
yung
let
for
me,
the sub BM dyan,
yes,
0.4977 po siya.
for this one, if you substitute.
Pag yung substitute po, 4977 po. Yung sa
Okay, sige.
PowerPoint po yung 4929.
Okay. Okay, so 4977. So let's make the correction there. And then, so that when you review, I'll erase this. I'll replace it with possible questions. Okay, possible questions. The first one is M. The second one is BM. Okay, and the third one, of course, is if this will be asked, no? Expected cost. And this time, you transition. When expected cost is being asked, if there's nothing mentioned, it's understood to be per T. This one, per capital T here. Expected cost per capital T, if nothing is mentioned. Okay? Now, possible questions for that is expected cost per capital T, or in this case, per week, or expected cost per year, expected cost per cycle. Those are the possible costs. But all you have to do is calculate expected cost per T and just convert it to whatever is being asked in the problem. So this is the most basic, the expected cost per T. And that is what your easy formula in the PowerPoint will give you. It is always per capital T. So therefore, here, let me just emphasize that this is cost understood, no? Since TR is 2 weeks, this is cost per week. Okay? So what's the formula? It's A over TR, right? So from there, you know that it's cost per week, right? So your A, so substitute na natin quickly. What is the A again? 30 divided by your TR, which is 2. That's the first part of the formula. And then you add the holding cost, which is 1. Okay, that's always per unit per T. Okay, since the holding cost is 1 per unit per week, then you don't need to do anything. That's the holding cost that you're going to use in the formula. So multiplied by M, which is 36.43, minus, okay, this is M, minus mu, minus 1/2 D times TR. That's the formula here. Okay. Now, the mu here is the mu of X. And that's why putting the subscript is important. In our earlier calculations for BM, it was mu of capital D here. Okay, it was always capital D because BM is per cycle. Here, the formula for the holding cost for one cycle is a function of your average demand during lead time. So always know that in the derivation of the average inventory level, the mean during lead time is the one that was used. So therefore, you have to put the average of X, which we had here in the given, this one. Okay, since lead time is 1 week and the problem says that the average demand in 1 week is 12 following a normal distribution, then we put 12 here. I hope that's clear. This is one source of mistake, right? And then 1/2 wait, lead time is 1 week, no? So tama, no? Average demand times 1. So that's 12. And then your D, small d, we also have placed it here somewhere. If we did not, then we have to put it. No, it's not here. So small d, again, based on definition, is the expected demand per T, which is per week. So per 1 week. So since the average demand for 1 week is 12, D will also be equal to 12 per week. Nagkataon kasi lead time and your capital T is the same. No? Kaya small d is also 12 per week. So clear ba yon, class? So 1/2 times 12 times your TR of 2. Okay, so that will be your total holding cost here. And then you add the back order cost, which is easy. What is the back order? 5. Divide that by TR, which is 2. And then multiply that by BM, which is what we got in the previous calculation. So since BM, you see here that BM 4977 is per cycle, we had to convert it to per week because cost is per week by dividing by TR, which is 2. Okay, so here, can I get EC? Just to differentiate it. In the PowerPoint, I think it's 28.67. Can I get EC?
28.67 din po.
Same?
7425. Opo.
Okay,
28.67.
Okay, 28.67. Okay. So for cost, if the problem does not mention, just do 2 decimal figures. And for others, you do 4 decimal figures if there is no mention in the problem. Okay. So we have 9 minutes. So let's see. Number 2. Number 2, I think I sent this. Number 3 is just for your practice problem. This was lifted from a previous exam. In the same way that number 2 was also from the exam last term. Okay. So you practice on number 3. Number 2. Write down the given. So what is 3 weeks there in the first line?
TR po.
Okay. So TR is equal to 3 weeks. Write the time dimension, para you don't get confused. TR is 3 weeks. Next line. In doing so, they incur a review cost of 12. So you know that review cost and ordering cost goes into your A. So you have to look for the ordering cost. So you have 12 as your review cost. You have to add the ordering cost, which comes in the next line. Very simple, di ba? Cost of paperwork associated with placing an order is 105. So you have 12 plus 105. That will be equal to 117. Next, holding costs, okay, is 0.5 per unit. Walang time element, di ba? So pag walang time element, understood na yan per capital T. Okay? Again, ulitin ko, if in the problem, the holding cost is given without a time element or dimension, then you assume that to be capital T. Okay, so H is equal to 0.5 per unit. And since TR is 3 weeks, then capital T is understood to be per week. So lagyan natin dito. Okay, your T is understood to be weeks based on this one. Okay. Next, a penalty of 15. So you have P is equal to 15 per back-ordered unit. Okay, that's your penalty. Next, supplier lead time is 2 weeks. So this time, L is 2 weeks. Ako na nagsusulat. Kaya I'm the one providing you with the given, but you just go line by line. Okay? Assume that the demand per week again, is normal. So just like the previous problem, demand per week is normal with a mean of 45. So take note that this time, in contrast to the first problem, here, first problem, we had X as the demand per week. Again, lead time is 1 week. And it says there that the demand per week is normal. So since the demand per week is consistent with the definition of X, which is the demand during lead time, then we used X. But here, X is the demand during lead time of 2 weeks. But the demand here is given as per week. So therefore, this is the one, no? The D here, okay, is the definition of D is the expected demand per T, which is in this case per week. So therefore, your D, that mean of 45 will now correspond to your D, which is 45 per week. Okay? And your random variable happens to be the demand per week, and it follows the normal distribution. Diba? Demand per week is normal. So, as I mentioned earlier, the demand per 2 weeks, which is your lead time, okay, the demand per 2 weeks will also be normal. And the demand per capital D, okay, let's do capital D. Let's do capital D. What is TR plus L? Total demand in how many weeks?
5.
Okay. Per 5 weeks, where 5 is your TR plus L. And this total demand, okay, has a probability distribution, F of D, just like what we did earlier. And this probability distribution, because the demand per 1 week is normal, then the total demand per 5 weeks also follows the normal distribution. Okay? And it will have a mean and a sigma. Okay? So now, just to practice what we learned earlier, mu D is, since this is demand per 5 weeks, and you're given the average demand here, 45, which is just for 1 week, then how do you compute mu of capital D? Anyone?
Multiply it
Times
by
5 po.
5, sir.
Ano ita times 5 ko?
Yung 45
D
po.
po.
Okay, so 45 times 5, that will give you 225 for 5 weeks. Now, you have to calculate sigma, but as I told you earlier, you have to do variance first. What is given in this problem is standard deviation, right? Here. This is standard deviation, 5 per week. So therefore, variance of 5 weeks will be what?
25.
That's the variance per week, right? 25.
Yes.
But what will be the variance of 5 weeks? So variance of 5 weeks will be, eto muna, di ba? Ang given sa inyo, standard deviation is 5. To get the variance per 1 week, you follow, you square it. Tama? To get the variance for 1 week, you square the 5. And then to get the variance for 5 weeks, you multiply this by 5. Do you follow? Do you follow, class?
Yes
Yes,
po.
sir.
So therefore, this should be 125, right? For 5 weeks. So since you required sigma, that's the time you get your sigma after you get the variance for 5 weeks. So sigma would therefore be square root of 125, or that would be equal to 5 times the square root of 5. This is very important, no, in the calculation if it's normal distribution. Okay? So again, sigma per 1 week. Okay? Wala tayong notation because D is the average demand for 1 week or for period capital T. Okay? Your random variable is just X and capital D. So therefore, the sigma for 1 week, ito na lang yun, ano? Sigma for 1 week is 5. You square that to make it variance for 1 week here. Okay, square it to make it variance for 1 week, and then you multiply by 5 weeks, which is your TR plus L. So then you get the sigma. I hope that's clear. So these are the two values that you need, no? This one and this one. Those are the two values that you need later. So once you have calculated that, you can now proceed to calculating ito. In this problem, tatlo yung tinatanong. Target level of inventory, expected number of backordered units per cycle, that's automatic, and expected cost per week. All right? So, start tayo sa M. So, as I've said, probability D greater than M, that you start with that, no? Is equal to, quickly, what's the formula? HTR over P. H is 0.5. TR is 3. Substitution lang to. Divided by 15. What is that equal to?
0.1.
0.1.
Okay, 0.1. Okay? And you now have an equation. So as I've said, this is just your Z. Okay, you have to look for the Z value. Since 0.10 here is area to the right, you have to do Z1 minus 0.1. Okay? And that is equal to, okay, hanapin na natin yung value sa table. So if you have a Z table, Z of 1 minus 0.1 or 0.9 in the table, ang pinakamalapit is 0.8997 in your Z table. So you can just look that up. And the value of Z is 1.28. Okay, when you review, please look for the Z value from the table. Practice kayo. Okay, so that would be equal to your M minus your mu D. Again, capital D ito because of this random variable capital D. So you have to have mu D, and we have calculated that to be 225. And then divide by sigma of D, which is 5 square root of 5. Okay, then from here, you solve for M. If you get mu and sigma correctly and the Z value correctly, then it's just formula. No? So M comes out to be, can you verify this?
Yes, sir.
Okay, 239.31. Thank you. And then next, you do the BM. As I've said, BM, if it's normal distribution, you go straight to the special formula. Okay, and that will be sigma. You follow this formula over here. Okay, this one. Okay, screenshot if you need to. Okay, follow that formula. So we go straight, sigma of D, we have calculated that to be 5 times square root of 5. Okay, so that's your sigma. And then you calculate your F function, di ba? F, which is 1 over square root of 2 pi times E raised to negative 1/2. And then, as I've told you earlier, this quantity inside is just your Z value. So your Z value is over here, 1.28. So you just substitute 1.28 squared. That's your F value over there. Okay, then you add. Class, are you able to follow so far?
Yes.
Yes, sir.
Okay, so plus. Formula is mu minus m. So your mu, what is your mu? Yeah, add natin dito. What mu will you use?
225.
225, capital D, kasi this is per cycle eh. Okay, so 225 minus your m, which you have calculated there, 239.31, multiplied by your G, capital G. And your capital G is always your critical ratio, which is this one. Okay, so you just plug it in times 0.1. That's your HTR over T. And so calculating this, can you please check if I need somebody to verify, huh? Is this correct?
Same po, sir.
Okay, thank you. Okay. Then the third one that's being asked is expected cost. And you will see here, expected cost per week, which is expected cost per capital T. Okay, 1 week. So that's correct, di ba? That's the basic naman talaga. Okay, so you have expected cost and that's A over TR. So balik tayo dito. A is 117. So you divide that by your TR of 3. So 117 divided by 3 plus your H. Your H is 0.5. Tama yan, no? Per unit per week, we assume. So 0.5 multiplied by, again, I will put the formula here. M minus mu of X, okay? Minus 1/2 D times PR. That's the formula. You know M. No problem with that. 239.31. What mu will you use? That's the mu is the demand during lead time. What mu will you use?
45.
45 lang? 45, remember, if you look at the problem, the mean of 45 is the average demand per week. Okay? What we want is mu of X, which is the average demand during lead time. So you now have to look at the lead time. Ang lead time is, ito, supplier lead time is known to be 2 weeks. So dapat, ang ika-calculate nyo dito is this one is the mean during what? Ilang weeks?
2 weeks.
Okay, mean during 2 weeks dapat. Okay, sa problem number 1 kasi, yung lead time was 1 week. Kaya kung ano yung mean for 1 week, yun na rin yung dinagay natin dito. Okay, sa problem number 1. Pero sa problem number 2, your lead time is 2 weeks eh. So if the demand is, average demand for 1 week is 45, then what should you do here? This should be 45 times anyone?
Times 2, sir.
Okay. 45 times 2, 90, represents your average demand for 2 weeks. Kung 45 per week, edi 90 for 2 weeks, di ba? Kaya importante, alam niyo yung definition. Okay? So then, you subtract 1/2, and then your small d is always your average demand per capital T, no? Per 1 week in this example. So, since you know that the demand per capital T, sinulat na yata natin yung kanina eh. Ito, oh, here. So, yan yung 45. Okay? So, that's times 45. And then TR is equal to 3 weeks times 3. So that's your holding cost right there. And then the last one is easy. P is equal to penalty cost 15 divided by your TR multiplied by your BM in number 2 there, no? So which is 0.5350. So EC comes out to be equal to, kindly check this if it's correct. Is that correct?
Yes po, sir. Same po.
Okay, so that's it. No, so for your practice, you do problem number 3. Okay. So by the way, for problem number 2, if for example I ask you for the expected cost per cycle, what will the answer be for this problem here? If I ask you for the expected cost per cycle, not per week, what will be the answer?
For 12.9, sir.
Okay. So example lang, if I ask you for expected cost per cycle, that will just be equal to your 82.58. What is one cycle? Go back here. One cycle here is TR plus L, which is 5 weeks. So therefore, all you have to do is multiply this by 5. So what is the answer? 412.9.
Yes po.
Yan. So ganun lang, di ba? Easy as that. So depends on what I ask, right? But I hope that the time frame of the problem is clear to you, no? Like especially this one, what to use in the expected cost formula. Okay? So for problem number 3, we won't solve it na kasi it's 12:42 already. So minax out ko na kayo. Okay, I just tried to recover the suspensions, but syempre I cannot. So I just leave you with the final answers. For problem number 3, this is the problem here. Same questions are being asked. Find the target level of inventory to be used every 3 weeks. Determine the, wait lang, is this every 3 weeks? Sorry, sorry. That one is mali. So, paano ko ba ito ibababa? Anyway, this one here, please change that to 4 weeks. Okay? Target level of inventory every 4 weeks. Paki-change lang. So, for number 3, your M, I just write down the final answers that I have so that you can check if your answers are correct. And if your answers are incorrect, chances are you made a mistake somewhere, no? So you have to recompute or you can ask me your questions. Pero Wednesday na kasi exam nyo eh. So until today na lang yung question. So you have to do it. Your BM, which is your back order per cycle, is and your EC. Ang tanong dito, expected, what is the expected, again, mali na naman yung pagka-type. No? What is the expected cost to, ha? Please change na lang. So dalawa i-change nyo. Every 4 weeks here and expected cost per cycle. Okay? So expected cost per cycle here is Oh, well, I don't have it, so it should be 147.53. And what is one cycle here? TR is 4 weeks. And what is the lead time? Here, lead time is 2 weeks. So this should be multiplied by 6. Can someone multiply?
Eight eight 5.18 po.
885.80. Okay, so those are the answers. You can practice with problem number 3.